it's Kayla.
And Jim.
And welcome back to another Meteorology Monday.
Today, we are going to talk about the super outbreak of 2011. April 2011 specifically.
Yes.
And we are deciding to do that today because it is the
10th anniversary. 10 years since this historical tornado outbreak has occurred.
Today we're going to talk about some of the stats. We're going to look at some of the maps, the radar, the satellite. We're going to look at some of the things back then. We're going to look at the storm reports.
Yep.
And we're going to look at the what the SPC put out in terms of the outlook and any mesoscale discussions.
Yep.
We're going to hit all the things.
All the things. We're going to do a little case study here since it is a monumental event and a big anniversary for it.
But before we get into all of that stuff,
make sure that you hit the like button and subscribe down below. Helps us out a ton, and you guys never want to miss another Meteorology Monday, so do it now.
So now we're going to start us off. Of course, the event lasted about 51 hours, but we're going to trim it down a little bit and look specifically at the morning of April 27, 2011, because that's when things really started to fire.
We went from interesting to some things happening to everything happening all at once.
That's right. So we will start from 12Z, for you meteorologists out there, which April 27th would be daylight savings time, so you're talking 8 in the morning.
8 in the morning. All right, so we are going to start with the surface analysis and move our way up to the 300 millibar level. We can see that we've got a nice front here. On the morning/day of the 27th, the majority of the tornadoes and supercells and stuff were in the southeast. We're looking at the Mississippi, Alabama area, a little bit of Louisiana. We're in that area right now. So things started over in Texas, so we're kind of moving over. We've made our way to Mississippi and Alabama. So as you can see here, we've kind of got our stationary front here lingering back behind, and we've got our squall line going through the middle of Mississippi and Alabama there, more over towards Alabama, and our low pressure is sitting over Indiana. Let's look at the next layer.
So that was at the surface, and the next level up is going to be the 850 millibar,
50.
or roughly 5,000 feet. Okay, so at the 850 millibar level, what meteorologists usually look for is a lot of low-level moisture. We look at lift. We look at a good low-level jet, which means winds coming out of the south or southwest here in the U.S., the southeast U.S. especially. So we're looking here about 5,000 feet up. And you can see down over the Mississippi, Alabama, Tennessee, Georgia. Can't forget Tennessee with this one. We've got a good fetch of southwest wind coming in off the Gulf of Mexico, and it's bringing in a lot of moisture off the Gulf of Mexico. And you can see that the green lines there are the dew points. So they're increasing as well. You can see a good pool of it there across the southeast. And then the winds, those are the blue flag barb looking things there. For those that are not meteorologists, you're used to looking at these surface charts and upper air charts. And you can see that they're in the, looks like there's 150 knots there in central Tennessee. And then, you know, a little bit below that, 35 to 40 knots down over Mississippi, Alabama, Georgia. So winds are starting to bring that moisture in. You got that dynamic low-level jet that's really cranking up. And so it's setting up the stage there in the lower levels.
Moving up to the 700 millibar, we can see that these isobaric lines have gotten closer together, and we can also see that our barbs and flags on those winds have gotten stronger. We're up to 60 knots here, or 55, 60 knots. So things are starting to pick up here at the higher levels, and you can also see across the US that nice little U-shaped jet going here. See how far it dips down? And those winds are coming straight off the Gulf of Mexico. The green lines again, the dew point. You can see a ton of moisture over Tennessee and Mississippi and Alabama, like we saw on the level below. So things are quite stacked on top of each other, and I think we're just gonna see more of that as we go farther up.
But first, before we move on, how many of you would like to see Kayla take a little quiz?
Oh no.
All right.
Okay.
The little quiz is,
put your hands down.
How many feet is the 700 millibar line?
You see, okay. These are the questions I always got wrong. So 850 is 5,000. The 700 millibar jet is, well, the 500. So I'm guessing like 7,000 10,000 and 8,000 feet.
No, you're a little below.
9,000 feet.
You're still below.
15,000 feet.
You're way above.
I don't know.
It's about 10,000 feet.
I thought the 500 was the 10,000 feet. Are we at the 500 millibars?
We'll get there.
This is 7?
That's 700 millibars.
You see, this is, okay. You know what?
All right, next level we're gonna go to is 500 millibars. That's
Which is, hang on, 15,000 feet.
No.
12,000 feet? Oh, hang on. It's smaller and smaller, and then it gets bigger. Hang on. So we're at like 18,000.
There you go.
There we
About
go.
18,000.
Hey, she remembers.
All right. So as we're looking, you're seeing the winds increasing even more so as you go up. So we went from the surface to 5,000 to 10,000. Now we're about 18,000 feet roughly. And you're seeing the winds come more out of the southwest, the south-southwest as you get down closer to the Gulf Coast. And then they start turning as you get up to Tennessee and Kentucky. And again, winds are very strong with this.
All right, we have made it to the 300 millibar level. And
Which
is, hang on, okay. So
how many
we're going
feet?
Farther
Take a guess.
Up,
Take a guess.
Up, so it's farther than 5,000, 8,000, 8 plus 8 is like. Did you tell them? That's not fair. 30,000, no, not 30,000.
Yes.
Oh!
About 30,000
I was like
feet.
29,000. They had us in the first half, not gonna lie. Back to meteorology. Here we can see we have got those little wind flag, wind barb things going, just following that jet. Look at that. And on top of that, we have this new feature. We have what is called upper level divergence, which is a key factor in spawning supercells and tornadoes. So what we have here is this huge jet, and as we're looking at this part that kind of starts in Louisiana and goes almost straight north here into Canada, we're gonna look at that portion of the jet. And for this divergence and uplift, we look at the either left exit portion of the jet or the right entrance. So if we look at that, the bottom half being the entrance to the jet, you can see that our area of interest is dead center in the middle of that right entrance portion. So just to have a jet set up like this is, you can't ask for anything more when you're looking for tornadoes and supercells and big events like this.
That's right. And for those that are not meteorologists, you're probably looking at it and going, all right, how do you guys figure out divergence, okay? So when you're looking at uplift, okay, so when you're at the 300 millibar level, roughly where the jet is, okay, you'll look for the area like over Alabama and over Tennessee. You see where the winds are very strong there, but you see them that they're actually going in different, almost different directions like this. So if you continue to follow the wind flow coming from Louisiana through Mississippi, and if you follow the one in Alabama and you follow the one in Tennessee, there's a divergent there. Well, the air that's diverging has to be filled in from somewhere. Well, it's got to come up from below. That's where you get a lot of significant rising motion. So meteorologists like to see divergence in the upper levels, and we like to see convergence in the lower levels. So if the convergence can be right underneath the divergence, guess what happens? So there's a brief little example. We didn't go into too much of the science stuff or get into the nitty-gritty, but that's kind of how we figure out the divergence.
All right, going back to the surface map real quick, we are going to step through all of our layers again, and we're gonna look at something specific. So let's pick this little wind barb here on the corner of Alabama and Georgia. And as I go through the layers from bottom to top, kind of notice what that wind barb does, the little flaggy thing, little blue flaggy thing. Ready? Here we go. Notice anything strange about it? It's doing that little swivel thing. In the meteorology world, we call that veering because it is going in a kind of clockwise direction, moving around like that. And that is an indicator of shear. So when you have, at the surface, you have winds going this way, and at the upper levels, you have winds going this way. It kind of gives that, that swirly, it kind of like if you drive past a bunch of leaves on the side of the road and the leaves start swirling because all the different winds are going different directions. That's what happens in the atmosphere, and you get those rolling motions that turn vertical sometimes. And that's one of the big things that we look for on the surface maps as you look at all of the layers together. Even
if you just think about winds going slow down here and winds going faster up here, this will naturally top over this, and you'll naturally get this kind of motion. And then what you need is instability or something to cause that rolling tube to go this way. And then that's how you start getting into mesocyclones and tornadoes. So we hit on a couple of things. We have to have instability, we have to have moisture, we have to have divergence, we have to have enough wind flow, we have to get all these components put together, and this is what meteorologists look for outbreaks. So there you have the maps and analysis of what meteorologists use. So now the Storm Prediction Center has looked at the same information as you just did, and now they're going to issue their convective outlook for the morning. And we will jump to that for right now.
So here we have the convective outlook. We have all of our pretty colors here. The green is thunderstorms, our yellow is slight risk, and then moving up in intensity, we've got the red for moderate, and then that bullseye of high risk right in the center there in that bright purple. And if you remember from the little maps that we looked at before, lines up pretty much in the exact same spot that we were looking. So you can see SPC, looked at those maps, saw what we were talking about just a second ago, and labeled the US map accordingly.
So now, before the main event occurs, the Storm Prediction Center, which is responsible for issuing severe weather watches, they have decided that the ingredients are all coming together. And they went ahead and issued a tornado watch for Alabama and for a couple of counties over there in Mississippi and a few of them up in Tennessee. Usually they do a watch box, and they usually define 2 points at the end of a box, connect the line, and then say, okay, certain amount of miles this way and that way of the line. So it kind of makes that parallelogram. And the counties highlighted underneath it are what fall within that box.
And as we're looking at this little box here, notice that it is a tornado watch, not a tornado warning. So this is just the general, hey, be careful, something might happen later today. It's not a tornadoes are on the ground everywhere inside this box. Moving on to another little view of that tornado watch, we can see at 1:45 p.m. they issued that tornado watch, and this is what the radar looked when they issued that.
That's right. Prime example of what Kayla just talked about is that there isn't tornadoes going on all over the place within the watch. You can see a lot of the radar cells are actually outside the area because they're actually moving towards it, and most of the area is kind of clear at that point. Now, with particularly dangerous situations where there's going to be very violent tornadoes, long-tracked, long-lived tornadoes, things along those lines, the Storm Prediction Center has got certain criteria that fall into that. So if that's going to happen, they will issue mesoscale discussions. And mesoscale discussions, they will have a graphic that they put together that shows some of the features that you've seen on the other weather maps. And they will highlight the area of interest of the mesoscale discussion, and they'll have a text description down below that talks about their forecast thinking on what's going to happen. And then they will put a banner across there that has things like,
tornado outbreak continues with destructive tornadoes through early/mid-evening.
So when you see that and you're in a high risk and you get an MCD issued, mesoscale discussion, you know it's going to be exciting.
It's going to be a day.
Next, we're going to show a radar loop of the storms that are blowing up and rolling through the southeast.
So now that we see all that is happening currently, let's pick one of the supercells that became a tornado. One of the big ones that day was an EF4 that went through both Tuscaloosa and Birmingham, Alabama. And we have some specific things for that supercell that kind of goes off of what we've already talked about, so we're just kind of breezing through it. But let's show you a little bit of what happened with that storm. Here is the storm. It gives you all of the times and stuff. This is the storm as it goes throughout the day. It starts actually over here in Mississippi, and it goes through those two major cities and Georgia, and then it keeps on going right into the North Carolina mountains here. Very long-lived, strong supercell that made it across 4 states here.
And if you look at it, so this isn't one one continuous line of thunderstorms. This is one storm that they took, and they just took the time and just kind of pieced them all together to show the train of its path. And what's really interesting was over the western side of Alabama and through Alabama, how you can see, can you find it? a very distinct hook echo, which is one of the telltale signs of that's a rotating storm and tornado.
That's a crazy strong storm to be able to last that long and make it across that much, space.
And as we talked earlier about how we have convergence coming in and then divergence, if it's long-lasting convergence and divergence over the same area or the storm got into it and is following that, you have a very prolonged storm.
All of the parameters that we talked about earlier are happening at all of these times out in front of the storm to keep this thing going for that long.
That's right. There's so many of them that are occurring. But just for the sake of the length of this video, we decided let's focus on one storm.
Focus on one.
Focus on one.
Here we have a snapshot of that same tornado that went through Tuscaloosa and Birmingham. In image A here, we've got the wedge tornado, and at this point it was an EF4. Going down below to image B, we've got the reflectivity, which is our regular radar. And you can see that nice hook echo going there with a little purple in the middle. For the reflectivity to be that purple, it normally indicates a debris ball. So you can see on the radar how much debris this thing is picking up. It was a major tornado. And then going down one more to velocity, you can see that red and green going back and forth, so that is winds going towards the radar and winds going away from the radar. And when you have red and green right next to each other, it shows that wind, kind of like that wind shear that we were talking about earlier, and it says rotation when you look at it on a radar.
And if any of this is confusing to some of those who are not meteorologists or just getting into it, we've got a bunch of blogs out on our website that talk about radar reflectivity and Doppler velocity.
And then just another quick image here of the damage path. So on the left is what it was before, and on the right is what it was after.
But we're looking to the southwest from high atop the Tuscaloosa County Courthouse. And again, we're going to stay with this as long as we keep power. If you watched us earlier this afternoon, we had a tornado just like that came through Coleman. I would suggest this might even be larger than the Coleman tornado.
I think it's much larger than that one.
Look at the debris. Look at the debris in that. Zoom in tighter, Jason, if we can go in tighter. Look at that. Goodness gracious. This will be a day that will go down in state history.
No, it certainly looks like a dangerous situation. I'm not sure whether it's winds rotation-wise on the velocities that I'm getting by radar. I think these transformers are blowing, I believe. The circulation with this, about 1.5 miles wide, that's likely what we're seeing in the picture there. A very wide combination of tornado and rotating thunderstorm whose updraft is basically all the way to the ground.
All right, a large wedge tornado right now, a tornado emergency in effect for Birmingham.
The tornado goes from here to there. You're seeing basically the prevailing cloud base and then the combination of tornado wall cloud comes down and the tornado edge right about there. So not very much difference between the rotating updraft of the storm and the tornado. Certainly would not be surprised if this was a violent tornado up in the EF4 range or stronger.
Okay, the last image we want to show you is the storm reports for the 27th of April. These symbols represent wind reports, hail reports, tornadoes from the 27th. And as you can see, it goes all the way from the deep south, Arkansas, Louisiana, it goes all the way up into New York. It was a crazy day. Crazy day. Like by far the most active single day for tornadoes and wind events and hail events that I think we've had in meteorologically recording records. So now let's go ahead and let's talk about some stats about the storm overall.
This is the whole event from the 25th, 26th, all the way to the 27th, 28th. So some quick fire facts for you guys. This tornado outbreak here in 2011 was the largest, costliest, and one of the most deadly tornado outbreaks in all of US history. During this outbreak, the National Weather Service confirmed over 362 tornadoes. That's like 100 tornadoes above the April average of tornadoes, just in this event. Not counting the rest of April. In all of April, there was over 700 tornadoes that year. There's normally like 200! What in the world?
Wow.
Next fact for you, this is a direct quote from NCEI right now. Until April 2011, 3 years had passed without a single EF5 tornado. However, this system spawned 3 EF5 tornadoes in only a 4-day span. And on top of that, there were 12 EF4s and 21 EF3s. That's an insane amount of strong tornadoes. And your last fact of the day is we have this parameter that we call the significant tornado parameter. Normally, if you can get the significant tornado parameter to hit a 1 or maybe 0.9 or like something close to 1, it's gonna be a good day. The significant tornado parameter for the area of interest on the 27th was anywhere between 10 to 12, which is over 10 to 12 times what we look for in a tornado event.
When the meteorological parameters set up just right for a tornado, you're looking at the STP to be about a 1.
Yeah.
And this was at a 10 or 12.
This means that there were every single parameter that you could possibly think of: convection, uplift, divergence, the fronts, the shear, the veering winds, everything lined up to like the maximum that it could possibly be to get a significant tornado parameter of 10 to 12. And this is the only time in recorded history that these numbers have reached that high.
All right, so for some of you people who are more old school, you remember the super outbreak of 1974 more than you do the super outbreak of 2011. I've got some stats here to compare the two events. So, looking at the duration in hours, and again, I've pulled these stats from the Weather Channel. They did a video on this back in 2013, so some of the numbers probably have been tweaked since then as they've done more research and the Weather Service has gone, okay, yeah, it was an EF4, not a 3, or it was a 3, not a 4. So, you know, some of the numbers might be slightly off. So looking at 1974 versus 2011, the duration of the event in 1974 was 24 hours versus 51 hours for 2011. Number of tornadoes during that time period was 147 in 1974, which would set the high bar. That was the bar up until 2011.
And then in 2011...
So on April 26th through the 28th of 2011, they had 293 tornadoes. So you went from 147, 1974, to 93 in 2011. So the number of states impacted in 1974 was 13 states. In 2011, it was 21 states.
21 states.
The number of deaths in 1974 wound up being 310. The number of deaths in the 2011 storm was 316, plus or minus. The number of killer tornadoes. Now this is where it gets interesting, okay? 2011 was the more longer duration event versus 1974. But 1974, number of killer tornadoes, 48 versus 29 in 2011.
And why could that be?
One reason is the technology has improved, the warnings got better, and people are now much more aware than back in 1974. The Weather Service has had a good outreach program over the past 3-4 decades now, and people become more aware, take the warnings not more seriously, because people were taking them seriously back in 74, but getting the message out there has become better.
It's become
the
easier.
Accuracy.
Everybody's got a smartphone nowadays, or a laptop, or a TV, and it's a lot easier to get that message out there compared to the Stone Ages back then.
We were chiseling warnings out on a rock, throwing it out the window.
Carrier pigeons. Tornado coming!
Blows the carrier pigeons away, nobody gets the warning. Okay, number of injuries in 1974, 5,454 versus 2,775. So there was about twice as many. Damage path, or total path of the tornadoes being on the ground in 1974, 2,521 miles versus 2,933 miles. So there was more tornado tracks, more tornadoes physically on the ground, but less people died, less people were injured. Testimony to Technology improvements, improvements in the Weather Service warning,
Construction improvements, perhaps?
construction improvements,
More
definitely.
tornado shelters?
People becoming more aware. Here's some other good stats here. Number of F2, because 1974 was still on the F scale, F2/EF2 and stronger tornadoes from 1974 was 95, but it was 77 in the 2011 event.
Oh, wow.
So yeah, number of F4/EF4 or stronger tornadoes in 2011 was 15, 1974. How many of the tornadoes out of the 147 were F4, F5 back then?
30?
30.
Wow.
30 of them in 13 states. Remember, this 2011 was 21 states. This was 13 states.
Wow.
And that's why 1974 set the bar so high that most meteorologists just went, we're not calling things a super outbreak, nothing's going to come close to this. And so when they actually did a comparison of all these numbers, they looked at it and they said, how can you not call 2011, April 26th or 28th a super outbreak? How could you not call it that compared to
It's very
the
comparable.
standard that was set April 3rd and 4th, 1974?
That is crazy.
So the total amount of tornadoes for the month of April, any April on record, the total number of tornadoes, 759. 2011 holds the record, right?
Yep.
The previous record was April 1974 at 267 tornadoes.
Wait, that's it? For the entire month of April? 500 more tornadoes!
That's the most of any April.
Goodness.
That's the most of any April. So now let's go to this one. The previous all-time monthly record, any month during the year, the most tornadoes. We're not just focused on April, we're talking any month now.
Any month.
Was 542. And April of 2011 was 759.
Crazy,
Incredible.
crazy event. Yeah, so I mean it wasn't originally called the super outbreak of 2011, and then eventually people started adding super to it after comparing it. And definitely an historic event. It's up there with some of the biggest, costliest, deadliest meteorological events in the US. Not even just tornadoes. I mean, it's been expanded to hurricanes and blizzards and everything. It's up there with the big ones of those as well.
That's right.
All right.
What a case study.
Oh my goodness. There's the case study. We've gone through some meteorology things. We've gone through some fun facts. We showed some video. If you guys like videos like this in the future, definitely let us know. If we went a little too meteorological, let us know that too.
We can tweak it. We're good like that.
But yeah.
Also, one other thing is that if there is a significant meteorological event that you know of,
Yeah.
let us know. Put it in the comments below.
Yeah.
Maybe we'll do a case study on that one too.
Yeah. If you want to follow more of our weather adventures, be sure to check us out on Facebook and Instagram. Our handle will pop up here. Until next time, I'm Kayla.
And I'm Jim.
Thanks for watching.
And happy super outbreaking.
You just made me question my entire college career. I'm like, I have to go and read all of my textbooks again.